Okay, adjustment procedure. We're going to calibrate this thing today. So it says, first thing we should do is adjust the power supplies. Okay. And it says we should adjust the plus and the minus 20. Okay. I've located the minus 20. And maybe that's the plus 20 there. Let's see, the plus 20 is on R925. And I'll have to go to here, R925. Yeah, okay. All right, so we have to get out some measurement devices here. And we will measure the, is that the minus 20 there? Yeah, there's a minus 20. And I had a screwdriver right in front of me. Where it is here? All right, let's see if we can't tweak this a bit. Sorry, that's off camera. I have 1999. That's pretty darn close. All right, I'm going to call it there. This minus 20.009. I say that's close enough. Now, where's the plus 20? It's labeled on the board somewhere, I remember. There's a 5 volts. Ooh, 5 volts exactly right there. Nice. Plus 20. Plus 20. Here's the adjustment. Let's see. Look, I read the things here. Plus 20. Adjust the plus 20 test point. Okay, doesn't really tell us where the plus 20 test point is, though. Here's the 5 volt one. The minus 12. Here we go. Plus 20. Okay. So plus 20 is right here. Okay, oh, that's the minus 20. Oh, do I have these backwards? No. Okay, perfect. Now I need to find the plus 20. All right, I found the test point. Let me adjust it a bit. All right, 20.000. Okay, good. Call that quits. Check the plus 5. I think I just did that. 5.004. Looks good to me. Adjust the beam current. Connect the positive lead of a DC voltmeter to beam test current located on the main circuit board and the voltmeter negative lead to chassis ground. Set the voltmeter to 2 volts full scale. Set SC secondary seconds per division to amp. Okay. And the intensity to control fully clockwise. Ooh. Okay, that's why they want you to have it off the screen. Adjust the beam R873 for a voltmeter reading of 0.4 volts. Okay. Where are we measuring? To the beam current test point located on the main board. Oh dear. Oh dear. Okay. Okay, I'm going to wait on that one. I just can't figure. I know where the adjustment is, but I can't figure out where the test point is. But we can do the trace rotation. Okay. Okay. Trace rotation is done. Adjust the geometry. Connect a 0.5 millisecond mark timer to form properly terminated time mark generation of the channel 1 input connector. Adjust the geometry for a minimum bow or tilt of the vertical lines. Okay, it just wants a fast clock. So we'll give it a fast clock. All right, so we're just looking to see if we have vertical lines. You kind of have to imagine a vertical line, so we can zoom in on it here. Let's see, we are triggering on that one at there actually, because this doesn't have, yeah, kind of hard to see. It's hard to do on a old scope like this, but I'd say it's close enough. Okay, just adjust that. We need to do preamplifier, set channel 1 to ground, volts division to 0.2. All right, so 0.2, ground, put it in the center. Okay. Let's see here. Using channel 1 vertical position knob, rotate the volts per division to 1M, which is way down here, and it's gone off. Okay. And now we need to adjust the step balance. Okay. Channel 1, channel 2, okay. I think that's this one here. Put it back down to center. Now if we go, oh, it's gone off. Oh, I see it. They kind of interact with one another. That one goes. I think I need to adjust my. Well, it's about as good as it gets on this scope. There is a little bit of offset on the bottom end, but that's okay. Change for channel 2. All right, channel 2. Channel 2. Put it on ground. Adjust the position. Now we go up and down. And now it's gone down a little bit. Okay, not good for that one. Adjust the input capacitance. Oh, I don't like this one. Adjust it for a flat top. I don't know, this thing looks pretty good to me. Preamplifier gain, set the channel 1 gain to rotate. All right. So I have a perfect signal for this. Make sure we are amplifying correctly. All right, so this is a waveform that I generated on the Rigel arbitrary waveform generator. And you can see it gives you nice voltage steps. And so here you can see that it's stepping 1 volt per step. And we're slightly out of calibration, okay? So we're a little bit low. So let's figure out where that is. Main, the T, blah, 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 rotate the volts per division. Volts per division. All right, so let's change the gain here. Set our position to exactly 0. DC, that looks good. Now we need to change our gain on channel 1. There we go. So I think we need to be like a there. All right, there we go. So here's channel 1. These steps here should be on the lines, and so they've been adjusted so they're all on the lines. And then it repeats, and it repeats exactly on this cycle here. So it's looking at both vertical and horizontal all at the same time. So it's a nice test to do. So we can take a look at this. It goes up and then it repeats and repeats. And then if you have it on the right scale, it's every single one. If I go to channel 2, we should see the exact same picture. Sugar on channel 2, and we see the exact same picture, right? So, everything's looking good on this little guy. Yeah, so maybe I'll keep them as a backup, or maybe if I have a friend someday who wants one of these things, I don't think it's worth selling on eBay. But yeah, it's a cute little scope. I like it. And I do need to fix the knob. Other than that, we'll call it quits. Yeah, I didn't go through all of the circuits, but for what I use it for in the garage, sometimes you just say, hey, it's close enough. I don't need to go through the whole thing. I'm sure there are others who want their oscilloscopes perfect, but for this little guy, he's going to be great.